Alright guys, in this video we'll be looking at quadratics. The quadratic we're going to be looking at is going to be written in general form. And the general form of a quadratic is y equals ax squared plus bx plus c. Now if you recall from algebra, when we're working with a quadratic, what we end up with is a U shape, which is what I have over here. And of course, depending on what the values of a, b, and c are, that'll change the look of that quadratic or that U shape called the parabola. Now there's certain parts of the problem that we're going to need to be familiar with. The first thing we're going to need to be familiar with is something called the vertex. And vertex on this graph here, on this parabola, is going to be this point right down here. This is what we call the vertex. And that's that point at where this graph curves. Now depending on what the graph looks like, that vertex could also be called a minimum, or it could also be called a maximum. And that's all going to depend on what the value of a is. If the value of a is a positive number, then we call it a minimum. If the value of a is negative, then we call it a maximum. So in this particular case, because of the way the graph is, we would call this particular one a minimum, and that's because it's the lowest point on this parabola here. Of course, if we had a graph that looked something like this here, this point up here would be called a maximum. Minimum referring to the lowest point on the graph, maximum referring to the highest point on the graph. And again, we can tell that simply by looking at the value of a. If a is positive, then we have a minimum. If a is negative, then we have a maximum. So that's one of the parts of the problem that we're going to need to be familiar with. Another thing we need to be familiar with is something called the Axis of Symmetry. And axis of symmetry refers to the line that cuts our U shape or a parabola in half. So if we were to take this U shape and run a line down the center here, we would call this the axis of symmetry. Symmetry meaning the right side matches up with the left side here. Now, when we refer to that axis of symmetry, it is a vertical line, and anytime we want to write an equation for a vertical line, it's always x equals some number there. Alright, better yet, let's do this. X equals some number. And that's all going to depend on where it goes through the x-axis. In this particular case, it goes through 0. So this x-axis, or this axis of symmetry, would be written as x equals 0. Alright, so far we've got the vertex. We also have the axis of symmetry. Something else we need to be familiar with is the y-intercept. And just like with lines, this U shape has a y-intercept where it crosses the y-axis. And in this particular case, it just so happens to be right here where the vertex is at. And whenever we're writing a y-intercept, we're writing it as an ordered pair. So in this case, it would be 0, and then whatever the value of c is in our equation. In other words, whatever that is, that would be our y-intercept, 0, and this value out here. So far we've got vertex, we've got axis of symmetry, and we have y-intercept. We also have x-intercept. And the x-intercept would refer to where the graph hits the x-axis. Alright, so there could be one x-intercept, as we have in this particular case. The x-intercept is right here, touches the x-axis at 0. But depending on how this graph is drawn, we could also have two x-intercepts. And I'll draw you an example. We might have a U shape that looks something like this, where we would have 1, 2 x-intercepts. Let's see here. We may also have a situation where we have no x-intercepts. We may have a graph that looks something like this right here. Notice this particular U shape has no x-intercepts. So when it comes to x-intercepts, you may have 1, you may have 2, or you may have 0. And again, that's all going to depend on what the parabola looks like. Alright, so let's take a look at an example of a quadratic. I've got the quadratic y equals x squared minus 6x plus 8. And I've also got the graph of that quadratic. And that's what you see over here. That's that U shape called the parabola. And what we're going to do is find parts to this parabola. First thing we're going to do is find the vertex. Now, again, the vertex is this point right here on the graph where the U shape curves. And we want to know what is that point, what is that ordered pair. In this particular case, that ordered pair would be the ordered pair 3, negative 1. So my vertex for this graph is going to be at 3, negative 1. And because it's the lowest point on the graph, we have a minimum. So we're going to call that vertex a minimum. Again, it's the lowest point on the graph. Next thing we're going to find is the axis of symmetry, that line that cuts this U shape in half. So if I run a dotted line right through the center here, this is the line I'm referring to. That's that axis of symmetry. And because it's a vertical line, we always write it as x equals some number. So the question is, what is that number? Well, if you look at this vertical line, notice it goes right through the x-axis at positive 3. Therefore, the equation for this is x equals 3. So my x, or my axis of symmetry, is x equals 3. Now what I want to do is I want to find the y-intercept. We want to know where is this U shape hitting the y-axis. And that would be right over here. And notice that point right there would be the point or ordered pair 0, 8. Notice we could also find that same value 8 in the equation, and that's that 8 right here. Remember we said that we could find the y-intercept. It was always going to be 0 and then whatever the value of c is. So in this case c was 8, therefore my y-intercept is at 0, 8. Last thing I want to find are my x-intercepts. Now in this particular case, because of the U shape we're going to end up with 2 x-intercepts. We have one of the x-intercepts right here. And then we also have another x-intercept right here. So there's 2 x-intercepts. I want to make sure that I identify both of those. So this first one here would be at the ordered pair for 2, 0. That's this one right here. So that's one of my x-intercepts. And the other one we have here is 4, 0. So the other x-intercept is at 4, 0. So in this particular case, we have 2 x-intercepts and they are at 2, 0 and at 4, 0.